Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video, I'm going to show you the magic of the function reshape from Numpy module. We are going to see in an example that if you know how to work with this function, very powerful function, a lot of your data pre-processing that you may have been doing by sort of like typing the code yourself can be done in just one line of code in a very optimized way. Alright, so you don't want to miss watching this show, because if your data pre-processing can benefit that reshape, it's going to be a game changer. Alright, let's look at it. Okay, so of course we're going to import our NumPy module. That's what we are using, this module, this powerful module. And then we are going to use the American Sign Language dataset. You can find this dataset on Kaggle. And I have already downloaded, and this is the folder in my computer. And I can use NumPy and matplotlib to sort of like show me these one of these images, right? I could be looking at different one of them, right? For instance, this one, I can get the NumPy, the image to be shown to me, and this is just one of those images. And also you want to pay attention, this image is essentially a bunch of numbers that is processed to show this image to us, right? So if we have numbers, we can start using these numbers to become more effective in analyzing them, and use the power of analyzing them. For instance, in this case, we're trying to see if we can use data science machine learning algorithm to be able to distinguish between the letters for sign language, right? So basically what we have under the hood are these numbers, right? And the shape of these numbers, for one image, you've got 400 to 400 columns and rows, and each pixel has 3 numbers. So each pixel has RGB numbers, a number for red, a number for green, and a number for blue, right? So each of these images are 400 by 400 size, and each of these pixels is a combination of 3 numbers that we have as red, green, and blue, right? So this is the under the hood. This is the numerical representation of the same this picture, right? So now we want to see how this magical function that reshape can help us actually take a very important step toward being able to apply machine learning data mining algorithms on such a data, right? So let's actually create a big data, create a data that has a lot of these images, right? So we need to have more than just one image, right? So I am using the OS module here to start reading these files. So these are all the file names, right? So I'm paying attention that I'm just using the letter A, right? There are there are different letters in this data set, right? So it's a huge data set. Only the letter A has around 6,000 images, right? So this is 5,996, and I'm going to read all of these into this data, right? You see, I'm using NumPy to create a placeholder, and I do know that these are going to be those dimensions. So each one of these is sort of like the shape of an image, and I want to have 5,996 of them, right? So I create this placeholder and I start reading these files one by one by this function from matplotlib, and input it into this part of the image. So I'm all of these are going to be used for that image, and then this is that index of that image, right? So this process will take about a minute to finish. So once it's finished, it's done, we will start sort of like this video. We'll like get back to this video and we'll see how we can use reshape. Alright, so the loading of the data is over. It actually took around 2 or 3 minutes. And you can see that it's already a kind of like a large data set. And we could be sort of like still using this plt.im show to still access and show these images, right? They can get access to various these all images, right? So we still have the whole data, but we load it into just one Numpy array, right? So the shape of this data is, you can think of these shape of one image, and these are the index of all of our images, right? So here's the magic here, right? Most of the time when we need to use any data mining algorithm, most of the time the data that we need is just a simple tabular form. We've got rows or data objects and columns are attributes, right? But this data has this other shape, and the Numpy reshape function, you can just prescribe the shape that you want Numpy to put the data in, right? So of course your new prescribed shape has to be aligned, meaning that you have to have the same number of numbers, the same number of elements in the original shape and in the prescribed shape, but it kind of figured it out in a very smart way and does this part of pre-processing in a very efficient way, right? So once we just click at this is kind of a large data set. You see how much it took for it to be loaded. It just instantly did the reshape for us, right? So now this is what we are familiar with. These are my number of data objects, right? 5,906 images, data objects, and these are my columns, right? I could start using some data reduction and also do some, classification, clustering, or whatever that I want to do. But the magic of reshape doesn't end here. You see, we kind of had to calculate this value for Numpy, but we didn't have to, right? If we were to just specify -1, which basically signal to Numpy that figure it out, right? I don't want to figure this out. I just know that I'm going to have 5,996 data objects. Figure this out, right? It will calculate the same thing for us, right? So it will do the same thing instantaneously. We can also reshape it back, right? So we can use the function reshape and like put the original shape and reshape it back, right? And we can see the shape is the same, and also our data is intact, right? So we can like use different values to see that our data is intact, right? So if you have ever needed to pre-process such a data for your algorithm, you can see how can this be a game changer. Before you had to be separate, I have to put this part in my data, like do this in a code, but this reshape function just does all of that instantaneously for you. I hope this is going to be helpful for your data mining machine learning project. Until the next video.